This video demonstrates how to compute alternative standard errors of the least squares estimator. Start by setting the working directory to the local folder where you have the CPS data, and then open a new script window. See the previous videos for the details about these initial steps. Call the library to load the Excel data, and then load the CPS data in the Excel format. And then format the data in the R's data frame. The head function displays the first few records. As usual, let's construct the wage variable from earnings, hours, and week. As in the previous video, we conduct a sample selection based on the years of experiences. We construct the years of experiences from age, years of education, and 6, at which the compulsory education starts. Now we construct the subsample indicator based on the race, the marital status, the female indicator, and the years of experience. So we are focusing on the married black females with 12 years of experience. As in the previous video, let's construct the X matrix as the education concatenated with the constants. The Y matrix is the column vector of the log wage. And now we extract the subsample based on the above criteria. Let's copy and paste it here. We also store the sample size as the first dimension of the X matrix, in other words, the number of rows of the X matrix. Likewise, we can store the number of predictors, K, as the second dimension of the X matrix. As in the previous video, let's construct the XX matrix as the X prime X and XY matrix as the X prime Y. Now we are ready to compute the OLS as the X prime X inverse times X prime Y. So far, we have replicated the code from the last video, but let's double check if we have the correct numbers. These are correct numbers for the OLS estimates. So now let's move on to the calculation of the standard errors, the main topic of this video. First, we want to compute the residuals. The residual is given by y minus x times the OLS. And then estimate the error variance sigma squared by the sum of the squares of these residuals divided by n minus k. With this, let's first compute the variance under the homoscedasticity. Namely, the V0 is simply given by the inverse of xx times the sigma squared. The resulting standard errors are given by the square root of the diagonal elements of this matrix. Now let's display these homoscedastic standard errors. We next compute the HC0 variance. Let's first focus on the middle part of the sandwich worm, given by the transpose of x times the diagonal of the residuals squared times the X matrix. And now take the sandwich worm. The bread is the inverse of xx, the meat is the m0 from the above line, and the bread again. The standard error is given by the square root of the diagonal elements. Now let's display the results. HC1 is almost the same as HC0. So let's copy these lines. Change the 0 into 1, and here 2. The only material change is the finite sample adjustment. So this is the adjustment factor. Now let's check the values of the standard errors. Next, let's move on to HC2. HC2 requires the leverage. So let's compute the projection matrix first. The projection matrix is given by x times the inverse of xx times the transpose of x. So this is the projection matrix. Let's extract the diagonal elements. Assign these leverage values to the object called H. With these leverage values, now construct the middle part of the sandwich form for the HC2. The x prime part is the same. The main difference from the HC0 is that we are going to weight the residual squared by the inverse of 1 minus h. Now construct the sandwich form. Compute the standard errors. And display the results. Finally, we will calculate HC3. It's almost the same as HC2, so let's copy these lines. Change the numbers from 2 to 3. The only material change is to square the weight. Let's display the values. So these are the alternative standard errors of the OLS.